Okay guys, I think we're live. Let me share the link in the Discord server. Okay, here's the link. Okay, so let me see whether people are joining. Let me just go grab some water while we are waiting for a couple of people to join. Okay, I'm back, guys. Let's start. Hope you're all doing good. Day 5. We took the first couple of days to just explore tangential topics like seamless M4T the first day, and then playing a bit with GPT Neo X. But we finally converged last night. I've basically downloaded the datasets, and now let's go and analyze, calculate some statistics like the number of lines per datasets, just to compare that with the paper. That may be the first step we can do, and we can start and play with filtering and other processing of the data. So we can ignore the download of these other datasets. Let's just start maybe first to do is analyze the downloaded datasets, count number of lines, make a histogram. That's something we can do as the first step. And then slowly we'll start going towards the moment when we kick off our run. Okay. Let's see where we are at. So here are various datasets I downloaded on the last stream last night. Let's just see how that looks like. I also downloaded the Mind by text for the English Serbian direction just as a test. There was some failure that happened there, so I'm gonna debug what exactly happened and where did we download that data. But before that, let's kind of quickly go through these files, and let's try and iterate through all of these directories basically quickly and create that histogram I mentioned. So this is the English translation. Okay. We can calculate some statistics also just to see average line lengths and stuff. So that's some things we can do now. Okay. Let us start. I think we can use suffixes here, as that's where the suffix tells us which language are we dealing with. Let me just see how they've done it in the paper. Just a second. NLLB paper. Let's quickly see how they've done it. Let me see. I saw some histograms before. Let's quickly skim through the paper. Okay, there is one here. This is the quality of Flores. Depict the quality assurance score for the languages in Flores. The minimum acceptable standard is 90%. That's not the chart we're looking for. We are looking for, that's the LID score distribution for some languages. That's not it. XSIM error rates, that's again not it. Okay, here's one. This is ablation dataset count. The amount of training data across all language pairs ranking from 40K to 18.7 million. Is there an actual chart for what I'm looking for? Okay, what is this? Toxicity detectors. Again, that's not what we care about. I just want to see a distribution across languages. Maybe in the appendix section. Let's see. Okay, language pairs. This is it. Distribution of amount of training sentence pairs across 1,220 language pairs in our dataset. We observed that the majority of pairs have fewer than 1 million sentences in our low resource. So 10x, 10 to the power of 6 is where, okay, so all of these here are high resource or mid resource, and the other ones here are low or super low resource, very low resource, how they call it. Hi Mirko and hi Sergey, welcome guys. Just going through the paper to find some histograms, and I'm going to calculate those myself now for the data sets that I downloaded using the download script yesterday from the FairSec NLLB branch. Let's see what's up here. Is there anything interesting we see here? Okay, I don't see anything. Really, I'm hyped up to start writing some code. We'll be just analyzing papers and code bases, and finally we're gonna start writing some code. Let me jump to one of the appendix sections. Okay, so let's see whether we have any reasonable chart here. No, that's not it. Okay, I think we can just reconstruct something like the page we saw above. Give me a second, let's find it again. It was somewhere here. Okay, here it is. So logarithmic scale on the y-axis, the count. We can create something similar, maybe not exactly the same, but let's see. Okay, let's go here. A useful thing would be to open up some code, language code page. Let me just find that one. We can close the GPT-NeoX stuff. This is for the mining, inference. We can close all of that. Where are those codes? If anybody finds it before me, please paste it in the comment. Okay, here are some codes that the laser code base supports, but let's see. Maybe we can open up Wikipedia. I think this is the this is the one. Okay, and then we can see what's AAU. What's that? Which language is this one? Or is this? No, this is just the name of the data set. So AMH is Amharic language. And then there is this ORM. What's ORM? Oromo language. Interesting. And then there is the TIR, Tigrinya language. Okay, basically we just grab the suffixes, and that's how we know the language code. So AKA Akan language. So let's create a quick script to just count the number of sentences. So the structure is not the same everywhere. Here we have one directory and then subdirectories and then files. Here we have directory and then files. So we can maybe just look for the files, do some OSVOC. Sounds good. Let's do it like this. Let me create a file called analyze data.py. And then just set this on my other screen. Okay. So we need the root directory, which is the data. Copy path. Let's just set it. Import OS package, root, and then for files, let me just quickly see what's gonna happen if we do this. Print file. Let's just create another setting for launch JSON. Launch JSON. No args. Let's pick that one. And let's run it. Okay, download by text because we actually have additional files here. So if they end up with py or zip, okay, now it's already getting inside of the actual directories. Okay. So maybe to make things a bit easier, we can create a separate directory and paste all of these data files there. So we don't have to filter explicitly. So let's just do something like this. All of these, let's cut them. And let's paste them here. Let's add data sets and then analyze data. We have one more data set here, but let's handle it a bit later. So now if I exit here, let's rerun this. Okay. There is a ton of files here. Let's just use their suffixes. There is one TSV file here, train TSV. Where does that come from? Train TSV. Maybe let's just find the set of allowed codes. I think that's the best thing we can do. Let's go to train directory. In fairsec, let's find train examples. Data. Where is the train directory? Wait. Was it in Stopes? No. Evaluation. Modeling. Here it is. Modeling. Configs. And then looking for the languages, floors 200, ablation lengths, scripts. Just a second. So we're just trying to find all 202 languages that we'll be using. And apparently they should be here. So under modeling, script, floors 200, ablation languages, maybe there. Under scripts. Why don't I see the... Okay, because it's not... Okay, here, these ones. These ones, and then we're looking for floors 200 and this. So let's see where we have... Is this 200 languages? Let's just copy path of this one. Let's go here. Let's open it up. Let's read the lines. And let's just print this. And then we will probably have to just break on the commas. Let's see what we get. We just get a list. Okay, fair enough. So we're just gonna grab the line 0. And then we're gonna split on commas. And that's gonna give us an actual list. And then let's see the length of that list as well. So maybe that should be 202. Oops, I have an error there. Okay, let's rerun. And indeed, we have 202 there. So let's see what's the content. Okay. So now to get the actual code, I guess we just need to split on the underscore and grab the first part. The second one tells us what's the script. And we also have to strip. Well, we don't have to because this will handle it, but maybe strip and then split. And then what we want to do is just filter this out. Let's try and use CoPilot here. Okay, fair enough. Please comprehension. We just split the language there and then grab the first part. Okay, let's rerun. I actually had a more complicated solution in mind, so this is better. So here are the actual languages. So now we're going to use this as the ground truth for the file suffix that we need, so that we don't fetch the TSV as the TSV language, which doesn't make any sense. So here is these are the supported languages. Okay. And let's go here. So for filing files, if file split on the dot, if the suffix is in supported line codes, in that case, we print the file. So let's just quickly print this. We should filter out the TSV now. Okay, as you can see here, we have a ton of files. And so now for each of the files, let's basically, let's open up that file, read the content and read the number of lines and add it to the dictionary with that suffix, if that makes sense. So let's just grab the, lang suffix or language code here by just doing this. And if the language code is in supported language codes, now here we can create just a dictionary. So let's see what we can do. Language, number of, how can we call this variable? Number of sentences or something like that. If you have a better suggestion for a better variable name, let me know. But we basically now want to first open the file. Will this work? Wait, we can't use theirs. We have to use, okay, this is probably just the root, right? I renamed this root directory. So now we want to open the file. So open up that file and then count the number of lines. CoPilot is doing an amazing job. Let's just verify this makes sense. So we open the file, and for each line we just sum like this, and we don't care about this really. And that's the number of lines, and then we just add that to the count here. Makes sense. And then at the end, we can just print the length of the dictionary just to see whether we covered, let's see whether we covered all of the languages. This might take a while because we're opening a ton of files. Let's just see we're running. We are not, because what? What's going on? Just a second. Sometimes my VS Code is just glitching, so that's also a possibility. Oops, let's just reopen this. Number of lines, and then just add it there. Okay. We should have added some login progress, but it looks like it's running. Yeah, CoPilot is super useful. I'm not like people who are bashing on or trash talking about large language models, including ChatGPT, CoPilot, whatever, these coding models. Like I don't think they really know how to use the tools. For me, ChatGPT is like for analysis of the code, and CoPilot is for synthesis. So I just use them as complementary tools. One thing I'll add for later is, let me just see. Okay. This is going a bit slower than I thought. I guess there is a ton of files. Let's just think about the histogram code we can make. So we now want to iterate over all of the languages. So by the way, we can later do language direction. That's more relevant. But for now, let's just see how much data we have per language. So okay, why is it stopping here? Looks like you went into focus mode, not talking for a bit. Difficult to be coding this all by yourself, thus streaming the entire process. I'm actually talking, like I'm not sure whether maybe my camera has frozen down. I mean, I'm streaming the entire process just because it's fun and maybe some people find it useful as a fun experiment, honestly. But this is definitely not the hardest task I've ever done in my life. This is fairly standard stuff, nothing fancy here, really. Okay, let me just stop this. Let's plot the histograms. Let's see, did we install matplotlib? Okay, fair enough. Maybe we can do bar. Okay. Let's just see whether we have. Yeah, luckily the code is already MIT code. We don't really, it's gonna be more about training than writing transformer code. I mean, rarely who does that nowadays anyhow. You usually have all of those implementations battle tested and you just reuse them. So let's see. I'm trying to do what? I'm trying to see whether the NLLB environment has matplotlib. Do we have matplotlib here? Nope. Let's just install pip install matplotlib, and then let's now run this code. Okay, let's see how this goes. Maybe just as a quick test so that we see that the histogram logic is correct, we can do the following. We can just break so we can test the whole code before we commit to waiting, if that makes sense. So let's run this. So number of files we found, 600 files. And then let it go. Okay, so here it is. We found 18 languages out of 202. Let's try and print these and see what we get. Did I close it down? Okay, here it is. Why do I have double figures? Okay, here is the histogram. Surprisingly little English. Is this a bug or just the fact of life? Let's see. Let's run the whole thing. Let's remove the breakpoints here. And let's just rerun this. So let me quickly verify this makes sense. So we go to the files, we grab the language code. If the suffix is among the supported languages, we just do some printing so we know the progress. We open that file, we count the number of lines, and then we store that into the dictionary for that language code. Oh my God, okay. This is a mistake because we want to obviously add the number of lines, right? We want to do this in a cumulative fashion. And then we can print everything here. Okay. That was a fairly big mistake. Aha, okay, because this is just a common dictionary, that means we have to actually maybe do from collections, import default dictionary, and then just make sure this is a default dictionary of ints, basically. Exactly. This should now work. Counting. You can probably see the progress here. Some of these files are much bigger, apparently, probably millions of lines. Especially English. So yeah, we actually have a ton of data. It's like 30 gigabytes only in this primary data set. So this might take a while. And then I'm gonna store this dictionary so that we don't have to rerun this code again. I'll just, at the breakpoint through the debug console, I'm just gonna save that as a pickle or whatnot. You can see English is taking a while. Is there an easier way to just do this? Maybe we could have, instead of opening the file, we can just run the word count command. So I saw a very nice piece of text somewhere, piece of code in Fairsec, where they're using exactly that to count the number of lines, which is probably much faster than what I'm doing here. We probably don't have to open the file to find the number of lines. That's potentially a piece of metadata for each of these files. So let's find how they do that. Let me remind myself, let me recall where did I see that code? Number of lines. Let's see, if I type in something like word count, L, other than the bare scripts, here is the command here. And then call the output, executing, check the output. Yeah, otherwise this will take just a ton of time. Let's see. Where did I find that before? There's this Schlux package or something, some Schlex. Was it Schlex? Yes, it was. Schlex split command. If we just call subprocess call, okay, this is not going very fast, but still, I think we should just implement it this way as well for some of the next times. Let me see. It might be in the Stopes repo, by the way, because Stopes deals with data more than this Fairsec repo. Can we just call subprocess call? Let's try one thing, just as a quick test. We go here. Let's create a dummy file. Temporary py. Let's cat a particular file. Let's cat the file itself and then just do piping. Will this work? And then word count and then number of lines. Will this actually work? Do we have to, I guess we have to call bash. Maybe. I'm fairly sure they didn't do it like this before. I'm not sure even what's the return variable. Maybe we can use CoPilot as well. Let's just try and run this. If anybody knows, let me know in the comments. I'm just trying to use terminal word count lines so that I don't have to open the files, which is slow. Let's see whether this is gonna work or not. Cannot execute binary file. I did get some number, but God knows what it counted because we have 4 lines only. Let's try and use CoPilot. Okay, now it's just using, I'm biasing it with this code above. So it might have memorized that, so that's gonna bias it. Okay, it's now printing just a bunch of statements. Will this actually work? Subprocess check output, word count length decode. This might just work. $11, that's not correct. Oh, it is. Oh, this actually worked, guys. Nice. It's not the exact same code I've seen before in the Stopes repo. Let me open up, actually I have the Stopes repo opened up here. Let me just find it, fairsec, Stopes. So somewhere in here, I found this particular command. Okay, here it is, bash pipeful cat pipe parts bin bash. Okay, something like this, I remember. This is how the file looks like. And then we just do cat. Okay, here is the exact line actually. So this is the thing I was looking for. Let's quickly copy paste it here, although this should work as well, obviously. Count lines. Import flex, and then there is this one. Okay. Okay, guys. Looking better. So This is a bit more generic than what we need for our use case, but it doesn't matter. Okay, we are done here. Let's see what's up. Let's open up this terminal. So we found 53 languages out of 202. So that means there is still a ton of languages that's not supported among the primary datasets we downloaded. So let me just store this dictionary somehow. So this one. Let's just save it. Let's just save the dictionary as a pickle or something. Save default dictionary to a file. We can pickle it. Will this work? Okay, where did it save it? Probably somewhere up there. Okay, it actually saved it as... Wait, will this work? NumPy pickle, what's this? Let me just repeat this without the pickle part. And then let's just attempt and load it. Okay, looking good. We just have to set allow pickle flag to true. I'm not sure whether this is the most elegant way to do this, but it works, apparently. We can delete this file. And so we store this one here. Let's go back to the execution. Let's step over bar plot rotation and let's show it. Okay, not really informative because a ton of these languages don't have a comparable number, so that's why we have to do a log plot. Otherwise we just see English. Interestingly enough, we have more Turkish than English, and then there is the Russian here and a couple of other languages. So it's obviously highly skewed towards some of these high level resources. Or okay, we can close that. Let's quickly analyze the logic we've done here. So flex join bash 5 parts. So we flex join this and then open file command. And then bash peepfall. And then we run that, we decode it. And we get the number of lines. Okay. Let's run this. Number of lines 54. Number of lines 54. They do the same thing. Why? One thing that I'm confused about. Let me just see. Subprocess run. This is more elegant solution. I mean, shorter, but both work. Let's now try and rerun the code with this. Okay, count lines. Will this be faster? I assume it will if it's using metadata in the background. So again, we just pass the file and count the lines, and then we add it up here. Okay, let's run this. This will either be blazingly faster than the last implementation or same speed. Okay, saying what? Non-zero exit status. What? Let's try it again. What's going on, guys? Probably just complaining about this. Okay. Definitely way faster. Okay. And we're done. Nice. Okay, that was a 101 how you optimize an implementation from a very nasty one where you open an actual file to count the lines versus just using some of these command line utils that probably just leverage the metadata in the background. Okay, let's now maybe just, yeah, so let's just save this again. Let's just save it as 2, just so we can compare that those are the same values, and then convert to dictionary, convert to numpy array, and then save. Import numpy as np, and then this guy, and so that leaves us with these two here. Let's just quickly load Let's just quickly load this. This is the first one. And then we have the second one. And let's see how can we compare the dictionaries. Can we just do P1 equals P2? Probably not. We probably have to, for dictionaries, how do you compare dictionaries in Python? Anyone? If you're quicker than what I can Google, so, whoops, you'll definitely be quicker. Compare dictionaries, Python. Do I have to actually... Can you actually use this? Doesn't work for nested dictionaries. Works just fine. The good old statement works. Interesting. Why is it then different? Just eyeballing this. Oh, there seem to be some small differences. 515, 514. Okay, maybe let's just, we can print out the differences a bit later. Let's just see whether this roughly looks the same. Yes. So again, English, Turkish, Russian, the modes of the distributions are here, and then a couple of other languages here. So we can close that down. Let's hit F5. Let me quickly first of all, let me just clean this up a bit. We don't need a separate file for this. Or maybe let's leave it there for utils, whatever. So we want to load these two dictionaries and just make sure what's the difference. Can we zip the dictionaries? Can I do something like this for... Okay, fair enough. That should be enough. Just a quick comparison to understand where the differences are. I saw it for English. NumPy array has no... Okay, obviously we're dealing with the NumPy array here. Let's just convert it to a dictionary quickly. Iteration over 0, what? 0D array. What's going on? Wait. How can I convert this back to a dictionary? Just a second. That's the price I'm paying for saving it the way I did. Now having to struggle how to actually load it back as a dictionary. Any ideas, guys? Let's see. Enumerate, flatten, what's this? What do we get if I do flatten? Is there any difference? Okay, maybe object. Hi there, Navjot. Welcome, guy. Why did I save it like this? How do I wait? What's going on? Why can't I just convert this to a dictionary? NumPy array, enumerate. Let's just try this random line from Stack Overflow. Will this work? Okay, and then okay, and type of this. Okay, well, we can do something super ugly, but because this is just a throwaway work either way, let's just do something like this. So we'll load, and then we can just do something like this. Oh my god, don't do this at home. Okay, and now this is actually a dictionary. This is a proper dictionary, and this one as well. Okay, so as you can see, a couple of languages are different depending on how we count the number of lines. So for English, off by 1. For Spanish, off by 1, and for whatever Lin is, off by 1. Okay, doesn't really matter. So we can just ignore all of this. Let's stop, and we can save that. Okay, looking good. We can delete the old implementation here and delete the comments I made for CoPilot. And now let's just try, let's measure, let's see the language directions. How can we do that? Parsec datasets. Let's see how can we figure out data direction. So here, basically, for each of these directories, we always have a tuple, 2 files. So that's how we can grab the language direction. And we can just include both. Okay, makes sense. Makes sense. Let's go back here to analyze data. Let's now do the same just for directions. Okay. For file in files. Let me just copy this, easier to copy it and then work there. So we want to assert that the length of files is basically 2 all the time. Or 0. And then we can actually do that here. And then go through the files. So we want to count what? We want to do number of lines is going to be the same for both files. and then we just add key is going to be equal to this. And then the second key we just duplicate that. And okay. Does that make sense? So we go through there, we assert that we either have 2 or 0 files, then we unpack the files, we grab the suffixes, the codes, we make sure they are here. If they're not, let me just log that. If they're not, skipping files. Okay, and then we count, we grab one of them, we get the number of lines, and then for both directions we just log that into the dictionary. And then finally we can comment out this one. Okay, and this is language direction. Okay, looking better. We can comment out this one, or we don't have to. Let's just see whether this makes sense. Maybe just to make it a bit faster. Okay. Okay, because when empty, we just skip. We count the number of lines, we get the direction, we get the opposite direction, and we just save. Okay, and let's put that here. Got one. Why? README. Interesting. Why would we have README inside of here? Okay. Well, let's then just do it like this. Good morning, SQ. Okay, and then let's basically grab the keys like this, and this should work. Hopefully. Okay. found 238 directions, which is 119 in one, because we double counted. Let's see what we skipped. It seems we skipped a ton of files. Why? Skipping. Why? Why did we skip these guys? Let's just see what's going on. So let's maybe just add a different statement here. So let's add, after this analysis, we are going to start filtering this data, processing it, and that's going to be fun. Okay. Let's rerun. Number of files found, too many files skipping, or too little. Okay, so apparently some of these don't have the codes we expected. Some of them are using the double letter, the only 2 letters for the code. Yeah, sure. I mean, I agree. I agree. This is not the nicest way to write it down. Yeah, but sometimes we have 3-letter codes. Sometimes we have 2-letter codes. So let's see. Why are we skipping all of these? That's why it's important to first analyze the data before you start processing. Just understand what's going on. Quickly, let's go. Okay, if it's different than 0, and then only if length we don't care about those. Let's for now comment out this one. Let's just make pass here and let's run. Let's first see when we are hitting this case. I'm interested to see when we are hitting this particular case. Okay. Okay. So too many files skipping. There is the README somewhere. And then it might be a good idea to just print the root directories. Too many files in skipping. Let's now do that. Can we just print as a relative path? Convert relative in Python. easier to read. Okay, indic NLP final repo readme. Where is the indic? Datasets, indic NLP. Okay, readme is on the top here. That's fine. And then in the dev, we have a ton of files. So how does one... Oh, okay. So I incorrectly assumed that we always have bytext. Sometimes it's n-way parallel corpus. So let's confirm that. So if we go here and we open up the same, let me just split this to the right. And then let's open up one of these. I assume they have the same number of sentences, which is a good indication that this is simply a n-way parallel data set. Exactly. So we have, if we grab this Hindi sentence, if we just translate it using Google Translate, we'll just copy that. Google Translate quickly Hindi. It gives me pleasure to welcome you all to New Delhi on behalf of the 3 billion people of India. On behalf of the 1.3 billion people of India, I'm delighted to welcome you all to New Delhi. Exactly. So we have, as you can see, what we have here is an n-way parallel corpus. So let me see what language is this. Interesting script. Odia. On behalf of the 130, I'm delighted to welcome you to New Delhi. Okay, it's kind of broken translation a bit, but what's Odia language? Just a small digression. Odia language, what's that? Where do you speak Odia? Eastern Indo-Aryan language in the Indian state of Odisha. Okay, so these are different. Okay, these are different Indian languages apparently, and again, all of them have 1,000 lines. So this is an n-way parallel corpus. Okay, this is a good insight. Let's go back to the file here. So now we can modify our logic so we can cover this case. So let's see what else. So we should be able to accept this. We just have to support the 2-letter codes. Let's see here, final repo test. If we go to test, we have cached lm test. Okay, and here we have Spanish and English, and then validation. Okay, this is actually my modification, so this is not meant to be like this. So let's go to Tico, English, Spanish. I played with this data, so I'm gonna quickly delete these. And also let me re-download, because I think I modified the train the files themselves. So let me go to download by text. No, download Parallel Corpora, and let me go and re-download the Tycho dataset. Let me just rerun this. So as to overwrite over my changes. Okay, here it is. It's gonna take a while to just download this. Okay, almost there. And then we can go back. Let me see what the README says, the Indian README. So if we go here, okay. Train dev and test set data for Indic languages task. Bengali, English, Gujarati, Hindi, Kannada, Malayalam, Marathi, Oriya, Punjabi, Tamil, and Telugu. Is Telugu an Indian language? Anyway, parallel consisting of 1,000 and 2,390 lines respectively. They are selected from the PMI dataset. This enables, thanks Abhijit. This enables the evaluation between 110 translation directions. We will only evaluate translations to and from English. Not all sources contain training data for all language pairs. The folder structure, dev, test, train, okay. Let's go back here. Just open up my window here, get some fresh air. Okay. Let's rerun this. Here we are. So first thing we have to do is add support for these 2-letter codes. I see them here. But let's see, where can we find that? Let's see where we can find that in the repo here. So we found this one on the modeling scripts floors 200 lengths. Let me just collapse the data directory. Okay, so modeling scripts floors 200. Let's see whether some of these are 2-letter codes. None of them are. Nope. And this is floors 120 and 101. So we don't care about that. Let's see whether they mention 2-letter somewhere here. 2-letter codes. Okay, this is actually the content of some of these files. So I doubt. Okay, double. ISO where can we find the mapping between, maybe let's try map. Nope. I'm certain we can find some mapping. Double. Here, sec. Data. Let's just see where it is. We didn't start training yet. We are preparing the data. Metrics. Code, looking for double 2-letter codes. Maybe some of the issues or something helps us find it. Maybe searching for 639. Nah. Six three nine one. Oh, nice. Here it is. Although this is just a minor mapping, we map to 3-letter codes. Is there anywhere that we can find complete mapping? Okay, let's just find If nothing else, we can maybe find it here in the repo directly. This is just, I don't see any mapping directly here. Data dictionaries, maybe this. Okay. This is the default script. Okay, nice. I think we found something, guys. So this is 322, 223, 322. We can just filter out all of these. Okay, let's maybe copy this. Let's copy that. Let's go here. And let us create a new file. Okay. And then we're going to do the following. We're going to leave only those that are in our supported set. So I'm going to import this here. Analyze data from code mapper, import language replacements, and then exactly. Okay. Let me just double check this makes sense. So we're gonna go from 3 to 2 and hope that all of these mappings are 2-letter codes. Something like this. Okay. Let's see whether this works. Let's stop this. Let's rerun. Okay, it doesn't even have all of these. Let's see. Not perfect. But we got some mappings. Okay. This is definitely not perfect. I think we'll have to manually do this unless, yeah, maybe you can in parallel try, if you have some time, try and find a good mapping between 3 and 2 letter codes. Maybe there's some package, but I don't know. We tried this one. It's not really comprehensive. Okay. Nice. Can we just download it from here? Okay. How many are there here? 7 through 211. 8 through 211. Okay. Maybe, just maybe, we might cover some of the ones we need. If we can just combine the two, if nothing else. Let's just make this a string and then we can parse it. Okay. Let's try this. Okay. So we can basically just drop first and last lines. Then we can strip let's just do some basic parsing. So here and then from 1 through -1. Let's see how that looks like. Okay. 204 lines. And then for each of them, if we do some stripping and remove the last comma. Okay, let's do that. We strip and we also just remove the last comma. Let's see what we end up with. This is it. And now we can parse these as, if I am to parse this as, let's see, now we can actually go like this. So we remove the brackets as well. Let's see. And then we just split on comma. Split on comma. Exactly. And also remove the double quotes. So once we split, we can remove. Can we do strip? We'll strip. No, strip will not remove the quotes. How do we remove quotes? Other than remove quotes. Is there anything more elegant than indexing? Okay, just replace. We can basically just replace the Okay, let's try this. Looking good, guys. Sorry, RPG, I didn't see your helpful message to use replace. I just saw it. Okay, replace. So that's it. Now we can do. Okay, I see there is a space here. So we split. Let me just see for a second. And maybe we can also just replace. Will this work? Okay, looking good. And now we just map the 3-letter code to 2-letter code. And we can then print that and save that as a variable. So we want to go from 3 to 2, right? So then let's just do it like this. Oops. That should be it. Here we go. And now let's just save that so that we can have a format like the above. Something like this. Dictionary. Dictionary like this. Okay. So if we just print we can just paste this. And voila. Okay, it doesn't have to be formatted correctly. We can just leave it like this. And we can remove this code or just comment it out. Let's just make it clear where we found it. Okay. Let's go back here. Okay. Let's try this. There are some that are not covered. Let's now combine. Let's combine it with the other one. Maybe there's some overlap. That might help. Let's just combine. So if we are, let's go here. Let's go here. Language replacement. Or let's just call that guy to creative. And then, so if the language is not there and not here, in that case, we continue. Otherwise, we try this. Otherwise, it's in one of them. So we can do like this. If it's in this one, then we do this. Else, we do this. Does that make sense? So if we can't find it in either one of these, sorry, not and. Actually, if it's not in this one or it's not in this one, no, only if it's not in both of them. That's fine. The logic makes sense. If it's not in both of them, only in that case we continue. Otherwise, we enter here. And we could put this logic inside of here. As well as here. Okay, let's see whether we have higher coverage. So 98 was the length. Let's see after this modification. PRS, what? Oh, sorry. I forgot to change this to 2. Let's rerun. Okay, 116. So we have a higher coverage now. Looking better. Let's print that new direct dictionary. Hi, Salvador. What's up, man? Just move this. So we can now move this logic. I'm just going to move all of this logic that we used to get the final one up there. I'm just going to comment this out. Okay. Looking good. Let's stop this. And let's now see. We're just analyzing the data sets we downloaded, and then we're going to do some filtering, processing, and try and kick off the run until tonight. That's the goal. Let's see. So, thanks, man. So if the language code is in supported languages, let's see if the language code, let's just set conversion here. That this might crash in the sense we might not cover all of the necessary languages, but let's see. Let's see. Looking good. And now let me see, we had the README file here, so we'll have to let's try like this. Okay, we might have multiple files. I forgot about that one. Okay, let's do like this. Let's just grab the line code and let's try and convert it. I'm gonna delete all of this mess a bit later. Let's just for now. Do it like this. Basically copy pasting the below code. So if we have more than 2 files, we go through the files, we grab the code, we try and convert it, and let's see whether that succeeds. So here is the code. Oh, sorry. So if the language code is equal to, if the length is 2, then we try and map it. Here is the language code. Try and map it, except could not map kin or English to so we don't have or there. That sucks. Let's just run this until the end. Okay. Okay, there's a ton of things we could not map. Why can't we map or if we have it here? Okay, this is, I made a mistake. Let's just combine all of them. Let's just grab this and combine them into this one. So, Salvador, I see you said it might help, but if you send the link, I don't see it because maybe the stream is just filtering out stuff. Let me do this. All the language pairs. Yeah, but we are trying, but there are no, I didn't see the 2-letter codes. We already have all of the language pairs for the NLLB. I found all of that, but we don't have, I didn't see anywhere the 2-letter codes for the mapping from 3 to 2 letters. So that's what I'm trying to do right now. So okay, and we repeat the same thing for the second one. Really? Can you send me the link somewhere? Because the reason I'm doing this is because I couldn't find those. Let me send me somewhere in Discord. CC matrix mappings. Where did you find those? Can you send it on general or even better in the NLLB replication channel? Search LNAI NLLB. LNAI NLLB. You mean, okay, you mean like, we actually opened up that one yesterday. Do they have the mapping somewhere? Yeah, I did. Just where, Hugging Face, language pairs, this one? Is there the 2-letter code though? Okay, there is the 2-letter. Yeah, but this is not, this is also not extensive, right? It doesn't cover all of the possible combinations. Let me see whether, does it even have OR? It does have this one. We might use this one as well. Thanks for this. Okay, so let's go and do it like this. So we found a couple of them, and then we're gonna just combine them. So let's construct the final one by going through the mapping 1, which we found here, by going through the mapping 2, which we found in this repo. Let me just note it before we lose it. Lang codes, this one. And then there is the third one you just sent, which we found where? Here. Okay. Okay, thanks for sending this one, the CC matrix mappings. Now we go through the mapping. If the key is exactly 2 and then the value is actually 3, just a second. So these ones are going from 3 to 2, 3 to 2, 3 to 2. Okay. So because it's a dictionary, even if we duplicate, it doesn't matter. Here we'll just have to find the 3-letter code. If it's 3 and this is 2, then just add it here. Let's see. Okay, we have 222 mappings. Interesting, that's a lot. Maybe just some quick error checking here. Let me just see whether... So this one is perfect. We know this one is 3 to 2, but this one is kind of messy sometimes. Okay. If we already added this one in the previous step, then just assert that it's the same as the value. That when we are overwriting, make sure that we have the same value as before, and same here. So if the key is already in the mapping, then assert that the value is the same. Okay, let's see whether we have any errors. Okay, there's some errors. MB, and now we have NO. Okay, guys, this might be a bit messier than I thought, because there might be more standards. There might be multiple standards of how to map into 2-letter codes. It's a good thing I've done this assertion. Okay, let's see. Let me think. Let's see. Let's just focus on the one. I don't know why we did this. Like, I wanted to really have this mapping, but we can just focus on the particular files that we hit here. That's gonna be simpler. So let's see if it's different than 2. Then we enter here. Otherwise, we're 2. Okay. Let's try this again. Okay. Let's just map these. Let's just note which ones we need. or GU EN TA MR PA Hindi ML KN TE test FM prob. What's this? KN, we already have that one. MR, we already have that one. GUTE, do we have TE? I don't, we have TE. TMPA, we have all of those. Okay, we have all of those. Let's see what this file is. In test, we have this prob file. Indic languages. Test. What's this one? Okay, some probabilities file. Whatever this is. So we need to filter that one out. Okay. So let's go back here. What we need really is a mapping for these languages. For now. Let's see. So there are two ways to represent OR. Is it ORY or ORI? ISO codes. We represent each language with a BCP47 tag sequence using a 3-letter ISO 6393 code as the base tag, which we complement with ISO script subtags. Okay. Okay. Let's see for the Indic languages in the README. Do they say anything about the code being used? ISO code, nothing. Let me just do the mapping. Okay. Yeah, it's painful job, but we have to do this one. We have to do this. Make sure we always map from 2 to 3, and then we can read those files. You map to Ori, and then let's see for this guys. GU, GU, GU maps to what? GU maps to GUJ. Exactly. GU maps to GUJ, and then BN maps to BEN, and then for English I assume it's going to be ENG. Okay, and then for TA we have what? For TA we have TAM, that's Tamil language, TAM, and then we have MR. For MR we have MAR, Marathi language, and then for PA we have PAN, and there for Hindi I guess it's gonna be HIN, but let's double check. Hindi, HIN, almost done. For ML we have what? ML, MAL. I can't believe they don't have a code table for this. KN, KAN, Canada, KAN, and TE stands for TEL. Let's see whether those are aligned there. TEL. Yes, okay. Anyhow, this is our mapper. This is our ISO mapper, ISO code mapper. 3 to 1. Let's go back to analyze data. Okay, let's start from scratch. I lost a lot of context while doing this. So we're trying to compute the number of sentences for each of the language directions. Let's do that. So here are the supported language codes. This is actually supported ISO 3 lang codes. Okay. So we go through the files. And let's just double check that that we covered everything we need here. Let's stop the run. Let's continue yet another one. Okay, so skipping some files. What's going on? Why these files don't have the... Okay, let's just print the whole thing. Analyzing data is always messy. Language code. This is not the language code, this is just a suffix. If suffix is there, then we add counter and the number of files is incremented. Else get zero-shot pairs. Where did we get this one? Get zero. Zero-shot pairs. Why doesn't this search work for file names? Why are you so lame? Okay. Let's rerun it. Okay, TSV, apparently it's not what we want. Some of these are corrupt. Analyze data. No, we don't want to go... Wait. Root is the data sets. Skipping. Control Shift plus P and then backspace for file names. What? Aha! Thanks for the tip. Control Shift P and then backspace. Thanks. Thanks a lot. Okay, so here we have a file additionally. Okay, so what's going on? We are going through the data we downloaded last night, and basically I'm analyzing some statistics, namely the number of lines for each of the languages and for each of the language directions. And then we found out there is some messiness in the data structure. There is no expected format, so we are now just cleaning. Not cleaning, but like figuring out what's going on and trying to calculate these statistics. And then we're going to start filtering and processing the data. That's the idea. Makes sense? Thanks for the tip, by the way. I always love that. That's why I love these streams, man. People always give me some tips, some small tips that you can learn a ton by just watching people code and and also me on the other side. Let's go. Okay, mostly NLLB seed. I didn't know we have NLLB seed. Just a second. Okay, under data. NLLB seed. Nice. And then okay, some of these. Thanks, Amrit. Thanks a lot. Okay. So I can't apparently just use the suffixes. So GAG is GAG supported. Let's see one thing. If we go to the floors languages, floors 200 lengths, let me do something like this. Let's go to modeling script. Let's go to modeling. Wait. So modeling script floors 200 languages. Is GAG supported? GAG is not supported. What's GAG? GAG is not even a language, guys. This is some weird stuff. SLR might be some format. SLR is also not a language. What's this? TIL. Let's see the TIL dataset. TIL. No, sorry, not here. Wait. Tokenizers, download other corpora. Okay, this is just for evaluation. We don't care about that for now. So, data, download parallel corpuses. Find the TIL one. Here is the TIL dataset. Let's go there. And then that's Turkic languages. And for some reason, a lot of these are not even supported. KAA. Yeah, I can't even find them here. Although this is obviously not, these are not all languages that exist. I'm not using LangChain. Let's just open one of these languages. Let's go to GAG. Let's go to datasets, TIL, alt GAG. Let's just paste this sentence into Google Translate and see what language we get there. Detect languages. Tatar. Okay, if we go to alt, what's this one? Kyrgyz. So Kyrgyz, let's see the code for Kyrgyz. The code for Kyrgyz is KY or KIR for the 3-letter code. Yet for some reason, here it's just denoted as alt. That's weird. And then let's see, maybe some other ones here. KUR. Why is that one not supported? What language is that? Let's see. Kurdish. Okay. Kurdish language. Let's see what's going on. Why is Kurdish not supported, or is it? What's the ISO code for Kurdish? KU or KUR? So that's good. That's a good suffix. Let's go to the paper. Central Kurdish CKB. It's a macro language. Central, Northern, and Southern. So, what do we do when we get a macro language? Sorry, Salvador, I didn't get your KMR, Northern Kurdish. Yeah, I'm just wondering, what should we do when we have KUR? Should we... Is that a combination of all three? How do we know which one of them is going to be inside? Or is it just like a dialect, so we can just lump it together into a single language? Not sure. One option we have is to basically edit let's maybe add KUR to our lengths code. Let's do the following thing. Let's grab this file. Let's copy it and paste it up there. Modified links. Hi, Reskin. Welcome. Let's copy path. Oh, Kurdish is your native language. Awesome. Nice. So what's the... So which is it called a dialect? Because I saw there are 3 different subtypes. Like there is a central, northern, and southern Kurdish. Which one do you speak? And what's the difference between those 3? Amazing. We have a... Wow. What was the chance? There's not that many people on the stream. Copy path. If easier, feel free to type down into Discord server, by the way. We have the channel here. I don't know if you're part of the server, but Meta NLLB replication, you can come here and just type it in. You speak Central Kurdish. Okay. What's the difference between Central Kurdish and Northern and Southern? Can you understand those 2 languages? We can call it extended. Okay, we'll do that. Okay, sounds good. I'll be following the Discord server. So what we can do here is what scripture do you guys use? If I put Arabic, will that be inappropriate? I'm just trying to extend this to support. I'm not sure if it's Arab. I might make a mistake, but this is just a placeholder. We can just put whatever. Whatever. Okay, now we support that one. That's going to be included next time. And then there is the French. Okay, we didn't support French. Let's go to Code Mapper here. Let's just add French. Okay, and then, so now most of these are NLLB seed. So let's just pick it up. So you can see here, these guys don't have the suffix. They are just named in such a way. Okay, sounds good. Let's go to analyze. Yep, I think multiple Ethiopian languages are included. Give me a second here. Okay, let's go back to analyze data and let us add a different comparison. So if the file name equals, if file is in If the file is in this, then we add con plus 1, else if this, else if this. So we should now support all of these. And then there is the readme.py. All of these can be ignored. Okay, let's rerun this. We should be able to cover more of them now. Couldn't join the Discord at the moment. Let me just paste you the link in case you can try again. Northern Kurdish uses Latin script. Okay, got it. So they are like separate languages. Central uses Arabic script. Okay. And then the southern one code for Central Kurdish. Okay. Guys, I just realized how good of a project this is going to be, because there's going to be so many of you who know your own languages. I'm good for Serbian, obviously a couple of languages I speak, and then we're going to have everybody. People will be able to check whether the translation works, whether a data set makes sense, whether this is going to be awesome. I'm really looking forward to analyzing the data together with the community. You know Hindi and Marathi. I'm not sure whether can you find the code for Marathi so we can double check whether it's present in the data set. Wait, this is just a mess. Let me clear this. It's present. Awesome. Let me check the code. Yeah, it doesn't matter if you know it's present. That's fine. Is that also like also an Indian language, Indic language, or how? Yeah, we'll do. I'll host the code soon. I can just maybe even now. Let me create a fork. I'm gonna do that at the end of the stream. Let me just note it down. Just a second. Where is my Notion? We'll do that a bit later. So, guys, by the way, what would be super cool is if you could maybe review some of the data for your particular languages and write a summary in the channel there. That would be amazing. We can do something like that. We can organize like a small hackathon of data verification. What do you guys think? So we can literally organize a datathon so that people can verify the quality of translations of their native languages. Organize a Discord event. I'm getting some very good ideas by just analyzing this data. I'm really enjoying this. What did you use to mine the data? We didn't use anything. Meta did open source the metadata for the mined data set. And then LNAI folks literally reconstructed the original data set using those metadata, and it's hosted on Hugging Face. So you can check it out. Okay. What's up with these guys? Why are they not supported? What's AAR? Which language is this? Uh-huh. Yeah, I forgot. Okay, this is Somali. Somali language, like Somalian, like Africa, or why is it called ARR? Where is the? Let's find the ISO codes. Okay. Afar. What's this? Okay, this language is definitely not supported. Afro-Asiatic language belonging to Cushitic branch, spoken by Afar people inhabiting Djibouti, Eritrea, and Ethiopia. Somebody mentioned Ethiopia just a bit before in the chat. So we can ignore that one, apparently, because it's not supported. Let's see what this one is. ORM. Oromo language. Oromo, again, macro language. Also Afro-Asiatic language that belongs to the Cushitic branch. Native to the Ethiopian state of Oromia and northern Kenya, and is spoken predominantly by the Oromo people. Okay. Yes, Rajan, there is the channel right here in the server. Let me know if you can see it. You should be able to see it. It's just below the community section here under the project tab. So they support the West Central Oromo. Okay. If we go back to here, so as you can see, there is a multiple of these individual codes. So here it says 5, yet here it says 4. West Central should be GAZ. GAZ. Let's see what's going on there. So if we go to our list, GAZ, so GAZ is indeed supported. Here is the GAZ, but we don't support. Okay. So what do we do when such a thing happens? Because this might include some languages that we don't support. Okay. Maybe, what do you guys think? Maybe when we have a superclass, a macro language supported, maybe we can then just add it to the extended. If any of the actual languages from that macro language is supported, we can add the macro language code to our extended languages file. Let's maybe make some notes. You can't find it. Wait, are you in the server? It's not a it's a public channel. Everybody should be able to see it. Everybody should be able to see it. Do you see other channels? Let me know. Okay, let's continue. Let's just add a note. Let's add a note section. That's weird. Can you maybe take a snapshot of the channels you see and then please paste it in the general channel? That's a good point. Maybe many people don't see the channel because... Okay, just paste a snapshot in the general channel, please. Let me fix that so people can discover the channel because, yeah. It wasn't selected to show. So if you just expand it, you see it. We only support the West Central Oromo. Okay. Let's continue. Let me just ask one question. Is there this GAZ? Is it included ever? That might be a good indication of what we need to do here. So if we go to analyze data, do we ever have GAZ suffix? Let's see. And for now, let's just comment out this. Okay. Number of files we found. Okay, we never, you see that? We never get the GAZ. Thanks, man. Let me double check. Let me go to general. Okay, got it. So basically, it wasn't selected by default. That sucks. Maybe we can... that's a good point. Thank you. I'm gonna add a note to myself to make sure. Okay. So guys, as you can see, we never hit the GAZ suffix, which means we should include the ORM. They basically kind of ignore the fact that it's a macro language. So what we can do, let me just check one more thing. If this, or if it's just infix, if it's just present wherever in the file, let's see whether that's the case. Okay, so definitely never. Okay, so because of that, let's undo all of this. We can add that particular language maybe nice if you just say not answered, then whatever. NA. And then for Kurdish, what did we do with Kurdish? Kurdish again has 3 languages: Northern, Central, Southern. our friend told us here that there are different languages. Basically, the northern one uses Latin script, the central one uses Arabic script, and then the southern one, I'm not sure. But let's maybe see whether they include any of the suffixes for Kurdish. Let's see one thing. Let's go back to analyze data. Let's quickly go to Kurdish. Three languages: CKB, KMR, SDH. Okay, let's see what's up there. Okay, found CKB and found KMR. And here, what did they say? CKB is supported, but KMR is not, I think. KMR. Oh, KMR is supported. So we have central and northerns. Central and northern are supported. Okay. But when we get KUR, we have no idea what it is really, right? So, okay, if suffix is KUR, then let's print the file. Okay, let's just print this. So there is two files. Let's see whether we have Latin or Arabic. So now, is this considered to be Latin when you have? Do we have? Where is the person that speaks Kurdish? We had someone. Okay, Rajan, you actually speak Central Kurdish. Is this? What is this? Thanks, man. Awesome. Okay. Okay, that's the Latin. Got it. Thank you. So that means both of these files are actually mislabeled. And we should include it, and we did. So I basically extended. Okay, let's just add a note here. What's the note? Okay, KMR Latin. Sounds good. For ORM, now a good to do here would be okay. Let's go back to our analysis. I mean, later we'll do a more serious analysis. For now, we're just trying to, again, just a quick recap for those of you who didn't join on time. We are just trying to calculate the number of lines per language direction, and there turned out to be a lot of small details that we have to handle. So we're now trying to figure out different files have different suffixes. Some of those suffixes are not, language codes are not actually officially supported in the length txt, which is supposed to contain all 202 languages that NLLB project supports. But there are some variations. Sometimes they include macro language, sometimes it's sub language. So all of these complexities, we're trying to kind of figure out what's going on there. So let me stop the program. Let's undo all of this. Okay, let's rerun. Let's see where we are. So AAR, we are ignoring that one, right? And then let's go to NDE. What's NDE? That's gonna be fun. NDE. NDE. Okay, NDE, Northern Ndabel. I don't know how to pronounce that. Northern Ndabel. Northern Uzbek. Okay. By the way, I would love to do one thing. I would love to make you champions for different languages. So we can have literally create a list of people who are responsible for different languages. So Razan. everybody will get like a credential. You'll get the credit assignments on the repo once I create a repo. I think this might be a very good idea to engage people as well. So let me just add a note here. Okay, so this doesn't seem to be supported. ND, we can ignore it. It's this language called North and the Bell. I couldn't find I can't find the code basically. Let's just see. The code is definitely not in there. Wait. Kurdish. Let's see where the table is. So the table is here, page 12, 14. So pages 12 and 14. And the E is not there, right? If we go to page 12 and 14, there is no mention. Okay, definitely not mentioned. So ND, we can ignore it. Let's see this one. VEN. Venda. South Africa. Venda language. Okay, not supported. PUS. What's PUS? PUS is Pashto or Pushto macro language. Let's see. Pashto. Southern Pashto is supported. Pushto. Pushto. Okay. Pashto. So a certain language from this group is supported. So-called Southern Pashto. So it's a macro language again. Southern, Northern, and Central Pashto. So we only support Southern. If we knew, are these all Arabic script? Fun fact, I did learn Arabic back in high school. At least I knew some words, sentences, I knew the scripture, but like I haven't been using it ever since. Pashto, Southern Pashto. Okay, so that means PUS. Let's make a note here. What's the code for Southern Pashto? What's the code there? Awesome, thanks a lot, Rivaldi. Please, if you can, just leave a comment here in the channel so that we can basically make you the champion for French and Spanish. I also speak Spanish, but I'm not sure if you're native, obviously, then you're going to handle that. I mean, we'll certainly have native speakers for all of the languages I speak, so I will be probably just a person for Serbian language. So just leave a comment there. Thanks again. Let's go. Let me see. So Southern Pashto is PBT. So PBT. Thank you. Only supports Southern Pashto or PBT. So let's now see quickly. Do we have that suffix? Do we have this particular suffix? Let's rerun. Let's see whether we have Southern Pashto. Okay, I just have to comment out this one, add pass, and rerun so we don't clutter the output. Okay, apparently there is no PBT. So again, that means that we have to add PBT. Sorry, PUS. Let's just see whether maybe it's an infix. This is just preliminary analysis. Later we can obviously repeat this. Okay, there is the PBT. There is the PBT after all in the NLLB seed. Fair enough. So I'm not gonna put this, I'm just gonna say so let's just add PUS because it's supported. Later people can confirm whether it's actually the language that we think it is it Southern Pashto or not. Okay. Okay, looking good. Let's rerun. NDVN, we can ignore those. Let's see what's the FAS. Persian. Persian language, Persian macro language, also known as Farsi. There are two specific individual languages, Iranian Persian and Dari. Okay, let's see. Persian, Western Persian or PES. Small group of confusable language pairs found to be the most difficult for the LID system. Well, Bosnian and Croatian are confused because they're the same language, same as Serbian. They're at best they're languages, very similar, if not the same languages. So they support Western Persian, but they probably don't support the Dari, PRS. Or do they? They actually do support. So they support both of them. Nice. Got it. So let's then, basically we need to add let me just note that here. FAS. Okay. We do include that one. Let's continue. ARA, A-R-A. What's up with that one? I think this is good. I mean, obviously we'll be dealing with a lot of languages, so somebody needs to have a broad overview. I think I'm going to be that person. I love languages in general. So I think it's valuable to just get some familiarity with these codes, get a bit comfortable, analyze the data. I think later it's going to be easier if we do this right now, because I really want to support all of these languages. Let's see. ARA stands for Arabic. Okay, there is 28 actual languages, 28 individual language codes. That's a lot. And I'm sure a ton of them are already supported. Arabic. Mesopotamian Arabic, Azyadani Arabic, Tunisian Arabic. There's a ton of Arabic languages here. Okay, so that means we'll add, so ARA is Arabic macro lang. Okay guys, let's just add this. Okay. Next up we have, what's this? TIR. TIR stands for Tigrinya. Is that Ethiopian language? Tigray region. I know there is some fairly bad things happening. I think there is war in that region of Ethiopia right now, which sucks. I think we had somebody from Ethiopia in the chat, so you can comment if you wish. So Tigrinya is supported. Tigrinya is supported. TIR and then ethi as the suffix. Why not? I think there is a bit different suffix here. Let me just see. Those are in the Semitic language group. Okay. So Tigrinya, interesting scripture. It's fun that we can render all of these on our on the computer. That's cool. Let me do the following thing. Let me just see Tigrinya ET. Oops. Okay. I think that's just the language we need to support. TIR. How can we support it? Let's just add it here. So TIR is supported as ethi. So let's maybe just add TIR ET. Okay. Let's rerun. And let's add a note. Okay. What else? What else? What else? What else? As the suffix TIR ET, and then there is a TIR ER. What's that one? You thought it's gonna be easy, guys. There's gonna be a lot of data work. That's gonna be the hardest part. probably, as always, is TIRER. Why didn't we filter this one out? Suffix if file is in supported codes. Or suffix. The suffixes okay, now we should filter it out, I think. And let's see. Yes. Now let's see what's TIRER. So let's go back here. TIRER. No mention of that one. There's probably just some different scripture. So let's see if we open up one, if we open up and say ER, let's see the script. Oh, makes sense. So Eritrea versus Ethiopia. Okay, is there any sub-language? No, it's the same language. It's just which country, probably there's some minor differences, but they are not acknowledged. Okay, so that means okay. Huh. Do we want to filter out? Okay. For now, we can filter it out because I'm not sure. If there are any differences. Okay, for now we don't include it. Then there's the MSA. Is MSA Modern Standard Arabic or something else? Malay, no. Malay. 36 languages under it. We certainly cover many of them. Like Indonesian. Indonesian is supported. Malay. Let's see where they mention. Let's just go here. Malay. Balinese. Banjar. Just a second. Oops, not that. I wanted to just open the languages. Banjar. Okay, here is Banjar. And here is Banjar. So they definitely support multiple Malay languages. Okay. Let's continue. DIN. Let's go back here, DIN. Okay, this is not even mentioned. DIN, what is this? Let's then just open it up like this, and let's ask Google Translate to try and estimate which language this is, if it even supports it. Probably it does not. Luxembourgish. I doubt this is a language they speak in Luxembourg. That much I can tell. Let's see what happens if we just Google directly using this. There is not even content for this language on Google. Okay. That's gonna be fun. DIN language code. Y-O-Y. DIN. Okay, Dinka. Dinka-Sprache. Oh, maybe it might be from Luxembourg because it sounds like a Germanic. It's a Germanic language apparently. Let's see up here. So this is the ISO 6392 code. Why don't we have it here? This table should have ISO 6392. Yet DIN is nowhere mentioned. Okay. Oh no, I mean, this whole table is in German, so. Dinka language. Spoken by Dinka people. South Sudan. Oh, South Sudan. This is currently the poorest country in the world, by the way. I recently watched this guy from one of the travel channels go there and create a documentary. It's just, situation is not really good. Dinka. Southwestern Dinka is supported. Okay. Let's just make a note. Let's make a note. I think that's the case. So Dinka, as you can see, there are multiple languages that are supported. Okay, let's go. So let's add din. Let's add din here. And then what else? GAG. Now there's a ton of these from this same data set. TIL. We obviously won't go manually through all of these now. So it's literally just the TIL data set. But let's just understand a couple of them. So what's the GAG? Let's just understand what's GAG. GAG, not mentioned. GAG language code. Let's just see if we open it up. Let's try and see whether Google Translate can help at all. Let's see. Let's paste this. Ganda. Okay, Ganda language. Bantu language spoken in the African Great Lakes region. One of the major languages in Uganda and is spoken by more than 5.56 million people. Ganda language. Okay. Sounds legit. Ganda is actually supported. But it's called Lug Latin. Okay, let's just see whether Lug Ganda. Why do we have multiple codes? Those are supposed to be unique. That's the whole point, right? Maybe it's the 639 too. Not even mentioned here. Okay. Okay. AZE. Let's see this one. AZE, Azerbaijani. Azerbaijani language. Why is this not supported? South Azerbaijani and North Azerbaijani. Okay, that's the reason why. So I assume it's gonna have exactly those two. Okay, got it. So we need to include that one, even though we're not sure whether it's South or North. So let's add a note. Both the north and south variants. Okay. Let's add it here. Again, what's the AZE? AZE. Okay. KRC. KRC. Not mentioned here because we're not on the main table. KRC. Not mentioned here. Let's just try and KRC language code. Karachai, what is this? Is this supported? KRC. Okay, KRC is supported. No, it's not. It's just results on this language are not even available. Okay, we're gonna filter it out for now. And then people can come and help us include it. Okay. AZE, again, this is, we've supported it. CHV, I think there's a lot of duplicates here, so we can just go through a couple of them more, and we'll probably support most of these. So let's see what's up here. What's the next one? CHV. Got it. CHV. CHV. Chuvash language. Turkic language. Apparently. Chuvash. CHV. Is that supported? Apparently not. But that's probably a macro language, is it? No, it's not. So Chuvash is not a macro language, and it's not mentioned in NLLB paper, so we can ignore it. Okay. So CHV, not mentioned in the paper, filtering it out. Let's continue. ALT. ALT, Maltese. Okay, ALT language code. Alt language code. This is definitely not going to help us there. Let's try and open it up. Grab a piece of text. This looks like some Russian Slavic language. Let's use Google Translate. Did I close my Google Translate? Apparently I did. Let me just quickly open up Google Translate here. Let's paste this in. The tech languages. Kyrgyz. Okay, let's see again. Kyrgyz. KRR. Okay, I don't see alt being mentioned here. Alt, Balto, Maltese, Balto-Slavic. Nowhere is it mentioned, so we're gonna filter it out for now. We're going to ignore. Alt. Kyrgyz. Chuvash. Let me just see where I noted that correctly. Chuvash, yes. Okay, let's continue. We can ignore the alt. Gag, we already went through that. SLR. Let's see the SLR. Again, not mentioned here. SLR language code. That's parser. Okay, it does sound like a programming language, not like as a human language. Let's see. SLR. If we grab this piece of text, of course Google doesn't translate most of these languages, but worth a shot. It at least can tell us the rough language family, if nothing else. Turkish. It says Turkish for this one. Let's see, Turkic. Is it mentioned here? SLR. Not mentioned here. So we'll ignore it for now. This is obviously not correct. Turkish. Let's continue. Again, gag. UZB, probably that's the Uzbekistani, something like that. Let's see. Okay, yeah. Uzbek. Macro language, Uzbek. Northern and Southern Uzbek. Uzbek. They only support Northern Uzbek. Okay. So let's say like this. Okay, so let me do the following thing. Let me add this language to the extended lengths. Okay. Fair enough, let's continue. We covered this one. KUM. 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 KUM is here. There is no code here. Let's see. Definitely not mentioned here. And if we open it up, we get again some similar language like before. What does Google say? Again, Kyrgyz. They say Kyrgyz for KUM. Okay, we cover this one. SAH. SAH. There is no code of that stored here. SAH. Saharan. Okay, not mentioned. And let's see what we get when we open it up. Again, similar language. All of these are similar script, like Cyrillic. Again, says Kyrgyz. Same conclusion there. Same conclusion there. So we can delete the alt here and just do it like this. Okay. We've covered UZB, TYV. TYV, not mentioned. TYV, not mentioned. And then I can assume that it's going to be again similar. Yeah. So I'm almost certain Google will say Kyrgyz for this one. Kyrgyz, yes. So we're going to add TYV. Okay, let's continue. Aze, we've done that one before. Aze, Azerbaijani. KAA. KAA. No mention there. No mention there. And this is the same thing. So we can just put it here. And then alt, we've done that, we've done this, we've done this, we've done this. Done KRC, I think we've done KRC. Yes. We've done. All of these are done. KAA, we've done this one. Yes. Let's continue. Alt, we've done. KJH. This is probably one of the last ones. KJH. There is no such code here. And it's probably just, again, yes, very similar scripture. So I'm just going to add KJH here. KRC. Gotta build my app now. See ya. See ya, man. See ya a bit later. KRC. KJH. We've done that one. KUM. Done. Alt. KAA. Let's just now filter out all of these that are filtered out. Let's just do that. Filter. Filtering it out. I'm not in the Bay Area. I'm currently in Belgrade in Serbia, actually. I might move to Bay Area at one point, but we'll see. But we can still collaborate on Datathon, and I'm gonna create some events in the Discord, so keep an eye on that. Basically, check out the channel here for the Meta NLLB replication, which basically will be tracking everything I'm doing in this stream. Because this is not the mine data. This is the public text we downloaded. This is a primary data set. Filtering. So again, there is these are public bytexts which the NLLB project used, and I'm just now trying to analyze what's going on in the public bytext. The mined ones are the ones where you, using neural networks, you find actual translation